Hello, good morning everyone, and welcome back to the session, the day 2 of the IoT Solution World Congress in Barcelona. For those who came yesterday, I hope you enjoyed, and for those who are coming today, I'm sure that you will enjoy this interesting day. First thing, I will introduce myself. I will be the host of this session. My name is Francisco Alferez, and I am the current president of the Spanish section of the International Society of Automation. Apart from this, I'm working at Tetra Pak, a global expert in process and tools. But before we get started, I would like to give a quick round of thanks to all the people that had been possible to make this event. I will start with the program committee volunteers that helped to prepare the program, and also to get the people to come here, this outstanding lineup of the speakers that we are going to enjoy today. Second, of course, the speakers, because without them, I know that you are very busy at your work, and I think, yes, your presentation will be very, very nice. Of course, the sponsors, because without their support, some of the activities we are holding today, it would not be possible. And finally, of course, all of you, because if you don't come here, also this event could not be possible. So without further delay, I will introduce our first speaker. His name is Pedro Rubio Blanco. He's Technical Service and Technology Director at Enagás. He has been working for more than 25 years in energy and gas sector, managing international national projects in the gas sector. Regarding his education, he is Master in Business Administration degree from IES Business School, and a mine engineering degree from Universidad Politécnica de Madrid. So I give you the floor. Please, Pedro.
Okay. Okay, thank you. Thank you for the presentation. And thank you to the organization for giving me the opportunity to present Enagás and our challenges that we are facing with the new hydrogen network. So first of all, I want to do a couple of considerations. Just first, I'm not an IoT expert. My background is engineering. So I'm going to speak about the industrial specific case for Enagás. It's almost a disclaimer. And the second is a consideration about the company. So Enagás is a company which is more than 50 years old. So we have technology from the 60s, different assets. So we are struggling with the data systems from that date. So we don't have we have many programs, but the problem that we have with the IT systems, they are not interconnected. So we have hundreds of them, but they are not interconnected. Then I've prepared the presentation in 3 parts. The first part is about an overview of Enagás and the challenge of the network. The second part is about specific examples on the evolution of the systems in the natural gas and the challenge just to convert into the hydrogen network. And the third part, I'm going to speak about different innovation projects that we are consideration for closing the gap between the natural gas and the hydrogen system. Just to start with the Enagás, so here you have the value chain of natural gas. So natural gas produced, filled, far away from the final consumer. So we need to transport this natural gas until the client, so with different methods. One could be liquefied in form of LNG. So we need to have liquefaction plants on the coast, shipping of LNG, and then terminals in the Peninsula Iberica. So we have another 6 connections, international connections. Some of them are sea lines, others are pipelines with Portugal, France. So at the end, we have 6 entry points in the peninsula, and we have around 500 exit points when we send the gas to distributors of final industries. So Enagás really are in the midstream, just only in the transmission system. We don't have any benefit on the trading of the natural gas. That's important because our main challenges are really technical. Technical just to maintain the installations, the assets, just to balance the network, just to have the same quantity of gas entry points and the exit points. We have a challenge with emissions of methane and CO2. So all our projects, technological projects, are in relation with these kind of topics. So we are then the independent TSO, transmission system operator for that, because we don't have this business on the trading. And as well, we are the technical manager system in Spain, GTS, Spanish, that we are in charge just to flow the different gas from the entry point to these exit points. This is more or less Enagás, and then the challenge for Enagás is really to be the hydrogen transmissions system of network operator, HTNO. Since last December, the government submit or send us the mandate, like we are the provisional for doing 3 issues. One is just to manage a planification for the network. The second is to manage the project of common interest that the European Union has approved for Enagás, and then just to participate in the different international agrupations like HTNO. Here is the energy trilemma when we need to do solutions for assets and information that have to be cost effective. Then the system has to be sustainable. So part of the transition, energy transition, is just to convert part of the natural gas into hydrogen, green hydrogen. And then we are a problem of secure of supply. So we need undergrounds, we need the capacity of the pipelines just to ensure that the final client has no problem at any time. Okay. So in terms of assets, what is Enagás? So we are in 8 countries. Of course, the main country is Spain, when we have more than 12,000 kilometers of pipeline. We have 6 LNG terminals to receive this LNG. We have 3 underground storages facilities. And we have more than 500 exit points, metering station that we call, where we measure the flow to the final client. That could be distribution or could be industrial clients. We are participating as well in Germany in a new LNG terminal study. We have a share on the Trans-Adriatic pipeline that came from Turkey, crossing Greece, Albania, Italy, and reach Italy. And we have a participation as well in the Greek TSO. Furthermore, we have participation in another 3 companies in United States, Tallgrass Energy, in Peru, TGP, Transportadora de Gas del Perú, and another project in Altamira, another terminal, and compression station in Mexico. In particular, in Spain, we have these 12,000 kilometers of pipeline, but we have more than 12,000 kilometers of fiber optics as well. So just to understand the problem of the historical problem of Enagás, we created the network with a cable of copper. And then in the 90s, we have to change to fiber optics, different cables with 8 fiber optics. And now we are installing more than 512 fiber optics per cable. So part of this network that we use to get for getting our information to manage the network, we have part rented to different companies to give them services. Amazon, Google, etc. So we are the first country in Europe in terms of capacity, and the 4th in the world after Japan, Korea, and United States. Okay. In terms of demand, so although we started in 1970 with Enagás, really the big improvement in the demand on the consumption was from 1988, 20 years, up to 2008, where we got 450 terawatts per year. From that moment, the demand has been stable. And we are supporting the electrical sector for combined cycles, around 20–25%, and the rest is just for domestic and industrial activity. So the idea for the coming years is part of this electric sector we could produce with green energy, renewables, and part of this conventional the main part, or a important part for the industrial that is difficult to abate the CO2. And this is the vision for the future European network in the backbone in Europe. The idea is that Europe is planning just to use 20 million tons of hydrogen in 2030. That is the goal for that time. And 10 million tons have to be produced internally in Europe. That means that we are creating corridors. We call this Iberian corridor, that where we put we match the production in Spain and Portugal, and send that hydrogen to Central Europe, overall Germany. So we are involved in the Spanish backbone. That is the blue pipeline in the presentation, and in the connections with Portugal and with France, the A2Med, we call the A2Med project. That is a line that's going to connect Barcelona with Marseille. The idea is that we have to develop 2,300 kilometers of new pipeline for hydrogen. This is a challenge in 5 years. We have to develop 2 underground storage facilities over in saline caverns. And we have to build the 2 connections for all this sea line from Barcelona to Marseille that is really challenging. The cost that we estimate in the investment, total investment, is around 6 billion euros. 4 billion euros is just for the Spanish backbone, and the other is a part of the total investment for the HUMET, where we are going to share with the another European TSOs, REN in Portugal, Gas, and Telega, France. With this HUMET project, they are going to continue with Hyphen. This is the project that reached Germany at the end. Just to develop this, this is the plan that we submit to the government last April. So now these are PCI projects nominated by European Commission. The 5 or 2 undergrounds, backbone and HUMET, the 3. And we need to build this project the time frame of 2030. That is the challenge for Enagás and really for all the market. Just to know how we prepared this pipeline, we did a call of interest with the market and getting the information from the production and the consumption. And with this point that they are in the blue and green areas is where we receive some interest for developing projects. So now the interest on this network is incredible. So we are just trying to get the main points, but the idea in the 10 years vision is just to complete the Spanish backbone, just to connect with the rest of this point where there are production and demand expectatives. Okay. So in this second part, I'm going to try to present you some examples of the different solutions that we have solved in 2 different asset life cycles. So for instance, in the natural grid, the main challenge was manage the documentation. Just for the operation phase, the problem was the SCADA, the supervision and control acquisition of data. And in the maintenance phase, that's important, very relevant for us, we have to develop a bunch of solutions. I'm going to present 3, the geographical information system, the asset health index, and the system for reading the metering different installations. But the challenge for the hydrogen network is to create a smart grid. And what does it mean? So, well, have to be digital native from the scratch, from the beginning. So we are working in building information modeling for the information, for the static information, that is the engineering and supplier and construction. We need to evolve the SCADA to a new one, just to include this hydrogen. We need to close the gaps between hydrogen and natural gas with those innovation projects that we are going to speak in the third part. So the idea is just to integrate all these solutions, the static, that is the information, the beam, the dynamic that came from the SCADA, and these are new information from these solutions for maintenance, and then for integrating these solutions is working in the artificial intelligence, just to solve the specific problem that we are facing with the natural gas. But as I mentioned before, the hydrogen is only to cover a part of the demand. So as well, we need to develop the not a digital twin, that is the solution that we are preparing for the hydrogen smart grid, but a little similar just to manage the huge information that we are creating with the operation and the maintenance. There are another two areas of interest for Enagás is the emission management for methane and CO2, but as well for hydrogen. So we have a couple of projects for trying to close that gap. And another relevant point for us is the metrology of the system. So in each metering station, we have different equipment of turbines, pressure devices, temperature, etc., that we need to calibrate in anywhere. So we have in Zaragoza a laboratory just certified by ENAC to calibrate these equipments and reduce the uncertainty of them. So I'm going to go a little in detail of each one. In the documentation management, the problem was that we had 300,000 paper documents from the construction, from the time that we create the installation, more or less until 2008. So we need a storage of paper, and looking for information to do anything was really very difficult. So we started to work with some platform for documents, Documentum, and now we are working with SharePoint. With the idea is just to try to speed up the looking for this information, to be more efficient and well. But really the challenge for us is just to create this building information model in the BIM. With this, we are going to create a 3D model where the engineering, the suppliers, the constructions company are going to put their information in only one base. So with this, we are going to create this static model, static information for the new hydrogen network. For the natural gas, maybe it's going to be very, very difficult because just to find and put all the documents in relation is just very difficult. In terms of SCADA, the supervision control, we are managing more than 52,000 signals in real time. So this is incredible quantity of information. With this information, we need to manage the system, flows, open, close valves, getting the information from the quality of the gas, about the metering, So really, we detected 3 years ago that we have a problem because we had a closed SCADA. So we didn't work on this system and then started to work in different applications, for instance, simulators, hydraulic simulators, that we need to control the flows. But could be for calibrating equipment, for have hundreds of solutions around this platform. So we decided just to go to a new one, SCADA, that is Monarch from Aussie, now AspenTech, it's changing every day. So, but with the idea that we need to comply with the cybersecurity, NIS-2 for us is very relevant, and overall the availability of the system, 99.999% for this one. But the good thing is that it's an open system. So they have solutions into the platform, into this SCADA, but as well we could work with our solutions and include it into the SCADA, the new SCADA. So we have divided the implementation of this new SCADA into phases. The first phase is in pre-production. We are starting now with this SCADA, and we are working just to integrate the different solutions. Maybe, for instance, natural gas quality tracking. This is a solution just to estimate the quality gas in every these 500 exit points. Is with a hydraulic simulator integrated, as again, for us, well, it's very important, and is able just to take in consideration the information for third parties, for instance, IMET, for weather, so we can predict how the demand is going to be with this information. So we could prepare the network, open the flows, the compressor stations, the underground facilities, just to match the production and the demand. The production is our terminals, LNG terminals, in a cost-efficient solution. Another problem that we are facing, for instance, is geographical information system. So it's a paradox that we have two Gs to do systems, one for the 12,000 kilometers of pipelines and another for 12,000 kilometers of fiber optics. So in case that we have a problem, we have to go, for instance, some third party cut a cable, and we need to go to reach the point where there is the problem. So we need to go to the GIS SCADA for the fiber optic, and no information at that time for the pipelines. So the idea for us is creating this smart grid where we can integrate in just one 3D model pipelines and fiber optics and the rest of the information. This future geographical information system, for instance, we are going to integrate right away. We have that cut on the fiber optics. We could have the landowner where the problem is. We could put in contact with him to notify that we are going to do to resolve the problem. And at the same time, we could have another environmental, if this is in an environmental protected area, etc. So for us, it's much better just to do the reparation. It's more effective, and we could go quickly to repair it. For instance, another example, we have inspection in line for the tube when we detect faults, potential faults, running a ILI, that is the name, the pig, and getting information through that where the problem is, for instance, a dent. So for us, it's very important just how to reach to this point, and then having information as well for the right-of-way, for the information from the tube, pipes, valves, etc. So the future of our future GIS is integrate all this information in only one. Other example that we need for maintenance. We have created, this is an internally solution. As I mentioned, our infrastructure, our asset, came from 70s, more or less, up to 2008. So we need to check how the pipes or the equipment are evolving with the time. So taking in consideration the information from the beginning, from the suppliers, and the real information for how it's working, pressure, temperature, etc., we could detect, we could prepare an index just to compare what equipment we have to repair, we have to change, or what kind of maintenance operation we have to do on it. So for us, it's relevant as well, for instance, to change or get out of the service tank. And the third solution, this is more related with third parties, with distribution and final clients, where they are managing they are trading with the natural gas. So they want to have what is the flows, what is the quality of the gas that they are injecting into the network, and what are the consumption in the different points, from this 6 to the exit point in this 500. So we need to balance, and they could go directly to this through this platform to their data, just to know if they are balanced, or they need to inject more gas, or they need to cut the gas to their clients. So this information is taken from the rest of the SCADA and the rest of the solutions. So it's relevant for the final clients just to go in depth and to have a real information in real time of this business. So they are doing a daily, hourly, daily, weekly, monthly balance, and they could be penalized if they don't comply with the GTS rules, with the national rules. And the resume of the smart grid is just to create this digital twin that is not indispensable, but could help us just a lot to integrate this static information from the beam, this dynamic information, and the information that we get from the maintenance applications. So we are working on it. So we could simulate hydraulic or any kind of problems just to make decisions on the network. And this third part, I'm going to speak about this innovation project, around 7. First one is the next Pangea, line 3. This project, normally, we work in consortiums with a company that they have the same perspective as us. And then here, with this project, we are working with this company. The idea, or the main problem with the hydrogen, is the failure for hydrogen embrittlement. This is a problem that we don't have with natural gas. We have to work. We are working in sensors, working with nanotechnology, carbon-based, that analyze the strength of the metal in real time. So through an algorithm, we could detect if we have a problem of this embrittlement, or is the tension in the tube could be because we have a landslide, and it's not necessary to do anything on the pipe. So we put these sensors on the tube during the construction and get information through the fiber optics and reach to this platform, this digital twin, or a digital platform for IoT. And we are capable to act before we have an incident or accident for hydrogen. That is very relevant for us. And that information as well, included into the digital twin, we could combine with another signals and detect, for instance, if the cycle on the tube is provoking another problem for fatigue, for instance. So for us, this is a very important project. With the next one, Pangea, we have another line of work. It's about measurement discrepancies. So with this project, we could simulate flows. It's a simulator of flows. So we can predict what are going to be the flows in the exit point, and we could compare with the real information that we have from the different equipment, the pressure, devices, etc. So in case that we detect some discrepancy, we could know if the problem is because, for instance, the turbine is out of service, or we have a problem because we have a leakage, or because we have an emission because something. Another risk that we are trying to close, and this project could be for natural gas and for hydrogen, is history new. So the idea is getting images from satellite, from the Sentinel, and manage this information. We could predict if we have any geological risk on the area, and as well go to the area and do some reparations on some activities before we have a break on the pipe. Very relevant for us as well, because overall, when we go for mountains, there are different high geological risks, the north of Spain, so we could predict if we are going to have a problem or not. This is more for maintenance. So this project is just to close the gap for detect emissions of methane. We were working on the GERC. This is a group of European research, together with another TSOs, European TSOs. And the idea is just to test with different devices, just if they can detect the emission. We provoke emission in the laboratory, and with these different devices, we could detect, and we know if they are the quantity of the leakage, of the emission. So we have tested fixed equipment, drones, trucks, and even we are testing with Satlantis, taking that sensor from the satellite, trying to quantify the leakage. With this GERC project, the idea is just to create a European standard. What are the equipment that we need to do for this supervision of emission? And you know that the European regulation this year, we have to reduce the leakage of emission to zero in a very short time. So we could detect, we could quantify, and we could act then in function of this regulation. And this project for the GERC, we are going to implement for hydrogen. But then, as well, we are working in another IoT project that is sensors based on fiber optic that could detect different temperature on the soil. We are laying fiber optic along the tube. We could detect in continuous if we have a problem, a leakage on the hydrogen. And as well, the project NIRA, that is an inventory of releases of hydrogen, we could compare what is expected and what is the reality. So take another action on the network in case that we consider that we have this leakage and how to proceed. And finally, the last project is the metrology center that we have in Zaragoza. So there is another gap. There is no laboratory for calibrating hydrogen equipment. No in Europe, no in the world. So we are building this new laboratory just to calibrate the turbines for hydrogen and different equipments. Is going to be certified by ENAC, that is the Spanish network laboratory. And our idea is just to create even the piston prover. That is the technology that gives us reference to the metro. So this is going to be reference for the rest of laboratories in Europe, just to compare with this calibration. For us, it's very important that the uncertainty of the equipment has to be very, very low. So you think that we have from 0.25%, we want to reduce to 0.17%. So it's a very, very small, but in a huge quantity of hydrogen or natural gas, the cost of the difference, these differences could be very relevant. In conclusion, Enagás has been developing information during these 50 years with not interconnected applications that we think that we could use for the future hydrogen network, but in an integrated manner with this digital twin. And for this gap, technological gap between the natural gas and hydrogen, we are working in these innovation projects that we as well are going to include into the digital twin. So I hope you can help us just to develop all these projects. So thank you very much for your attention.
Thank you, Pedro, very much for your presentation. We have seen that hydrogen is something that will come. The future is bright, but it's very challenging. I don't know if anyone have any question. We have some minutes before the next presentation.
Hi. First of all, thank you very much for the great presentation. I really enjoyed it. And to be honest, I never knew that companies like mine, a door producer, is such similar to a company like yours dealing with hydrogen, which was very interesting. I've got a special question facing the BIM, the Building Information Model. You told us that you integrate the BIM within your IoT system, within your smart cluster. Is it possible to have a bidirectional connection here? So within the BIM, you get the information from the smart cluster, and you can set up your digital twin within the planning?
Really, I'm not the expert on that. But the idea is that with this digital twin, we could do anything. It could be bidirectional. But for us, the important point is that taking the static information, that's information we are getting from the construction phase. So we need the information from the supplier, we need information from the construction, we need it from engineering, and integrated in this simulation, in the digital twin, we could, with the rest of the information, the dynamic and the IoT, the rest of the project for maintenance, we could detect any problem and then back to, so it could be bidirectional for both, for all systems. It's the same system, really. It's not there are no, it's only one integrated. So in fact, for me, it's not bidirectional, but this is the same.
Okay, thank you very much. I think that's very interesting.
Any other question?
Well, thank you, Pedro. All these innovation projects, all this new hydrogen infrastructure that is coming to Spain is going to generate a lot of data from IoT and from other components of the systems. What is your data strategy? How you do you plan to not only collect but also to store, to prepare, to analyze, and to take insights out of that data?
Now we have all solutions. We have on-premises servers. We have part in the cloud. We are working with Google, Amazon. So our idea is just to integrate in one platform, just to have integrated all the data. But the problem is when we face the different applications, so we have problem even for the common data that we need to assign to the different application. So we find a lot of problem just to integrate it only one. So the idea is just go to the cloud, just having all the information in one, but maybe it's impossible for natural gas and because there are hundreds of applications that we can't manage. But the idea is just having only one is the more cost-efficient solution.
Ivan Kravchenko, Germany. Thank you very much for the presentation. It was very insightful because we are also care a lot about the hydrogen network. I have not an IoT question, but basically, how are you going to manage facilities converting and producing the hydrogen? Because there are many methodologies and many sources. What's your strategy for that facilities?
This is not our business. I said that we can have any participation on the production. That is part of the independent TSO, no? I don't know exactly because there are a lot of variables on the production of hydrogen. Green hydrogen, first of all, the renewable energy is variable. So they need to send a quantity that we have to storage into underground storages facilities just to match with the demand. So I don't know exactly if they could, for instance, work on-off in the electrolyzers or depend on the weather. So this is really a question for the producer, for the electrolyzers suppliers. This is a challenge as well because imagine that we need to storage the double of energy, the double of hydrogen in our underground storages, just to give a flat consumption at the final client.
Yeah, that is exactly my question, because in Spain you have a lot of sun, so you have the possibility to use electricity and to dissect the water into hydrogen and oxygen, but we don't have that in Germany.
Well, in Germany there are a lot of projects as well. So in Germany, they are trying to get hydrogen from the rest of Europe, from the north. And,
we are trying to do.
But the problem is that the sun is interruptible. So during the night you don't have sun. So the topic there is the number of hours of sunny on the electrolyzers, on the renewables. But there is really a business problem for electrolyzers. But I think the first idea was just to use energy from the electrical network during the night. So the electrolyzer is working in a flat way. They are not on-off, and they don't have problem for maintenance, etc. But new European regulation is that we have balance. We have to do balance hourly. So when you don't have sun, you can produce green hydrogen. Could be another hydrogen. But now Europe is forcing to have this green energy just only for renewables. So that's a relevant question for the production.
I see. Thank you. One more question. So currently there are some trends for hydrogen cars. Yeah, so there are electric cars and hydrogen cars. Are there any plans for you to manage the fuel stations?
The what there?
To manage the hydrogen supply
for the fuel stations for cars?
So as it's the same as well. So we are not participating on the fuel stations. So if someone wants to connect to the network, they could do. There is another challenge because the fuel stations works to 700 bars instead of we are working in 100 bars for the network. So they have to put compressor in their fuel station, and the quantities of the hydrogen they need to the vehicles are much lesser. So let's see what happens. Maybe we use the hydrogen like natural gas for maritime transport. That is another topic.
Okay, thank you very much. So keep seated for the next presentation that will be in 5 minutes. Thank you very much, Pedro.
Thank you.